just want to quickly point out how to find the inverse of a matrix. First, let me describe real quickly what an inverse is, and then we'll talk about how to find it. Let's take the two matrices, 5, 7, 2, 3, and 3, -7, -2, 5. And I want to claim that these are inverses of each other. We know how to do matrix multiplication. If I multiply these two guys together, it turns out we get 1, 0, 0, 1, which is what we call the identity matrix. Now, this is the 2 by 2 identity. If we had a 3 by 3 identity matrix for 3 by 3 matrices, it's very similar. We've got ones along the diagonal and zeros everywhere else. So it looks something similar to this. But the idea behind an identity is whatever matrix you multiply times the identity matrix, like A times I, you're going to end up with what you started with. So A times I is going to give me A. The idea behind an inverse is that I'm going to claim that this is A and this is its inverse. So the idea behind an inverse matrix is if you multiply A times its inverse, you get the identity. And it's kind of like the concept we talk about in real numbers that 0 is our additive identity. Well, think about if you add 7 plus 0, you get 7. All right, and then we think of the inverse of 7 is -7. So if you add 7 and -7, you get the identity. So it's the same idea here. We've talked about identities and inverses and different concepts, but this is how it works for matrices. All right, now you're asked sometimes to find, how do you find A inverse? And again, in this particular situation, we already know what the answer to this is. I'm going to let A equal 5, 7, 2, 3. Okay, now what I mean by that is we already know that A inverse is this particular matrix, but how would I get that given A? And how do we find A inverse? We take our matrix in question and we're going to adjoin it to the identity and form an augmented matrix that looks like this. Okay, so for us, we've got 5, 7, 2, 3, which is a 2 by 2, but now I'm going to make it a 2 by 4 by attaching the identity to the other side. All right, so now we have a 2 by 4 matrix that looks like A formed with the identity. And I'm just going to perform row operations. My first row, to where I'm putting it in reduced form. So first off, like normal, we want to put the 1 in its position. So I'm going to do 1/5 times row 1, and that'll give me 1 7/5, 1/5, and 0. So that was a 7, 7/5, 1/5, and 0. And then the second row stays the same. All right, the next thing we want to do is turn this guy into a 0, our reduced form. And to do that, we're going to do -2 times our first row and then add it to the second row to get a new second row. All right, so we'll have 1 7/5, 1/5, 0. And our second row is going to be, let's see, this will be a 0, and then -2 times 7/5 is -14 over 5, plus 15 over 5 is going to be 1 over 5. And then we have -2 times 1/5 plus 0 is -2/5. -2 times 0 plus 1 is 1. All right, now let's go on to our next one. The next thing we want to do is turn this into a 1. So we've done this before. 0, 1, and that's going to be -2 and 5. All right, and I got that by multiplying that second row by 5. All right, so let me write that. 5 times row 2. And now for our last row reduction operation, we want a 0 in that position. So we're going to do negative 7/5 times R2 plus R1. Alright, so negative 7/5 times 0 plus 1. Negative 7/5 times 1 plus 7/5 is 0. Negative 7/5 times negative 2 is 14/5, plus 1 is 15/5, which is 3. And then negative 7/5 times 5 is negative 7, plus 0 is negative 7 in that position. And you see now we have an augmented matrix that looks like our identity first, and then A inverse, which we already knew what A inverse was, but here it is. All right, so that's a process we can do. We just use reduced row operation or Gaussian reduction, whatever we call it, use that process to find inverses of matrices if they exist. A side note on that, it turns out that if the determinant of A is not equal to 0, then A inverse exists. So sometimes you're going to come up with a situation where you're trying to find an inverse and there's not one. You can check the determinant, and that's a quick method for deciding if a matrix is invertible or not.